3.6, we're going to look at factoring polynomials. First, we have two theorems. The first theorem we're going to learn today is called the remainder theorem. So the remainder theorem states that when a polynomial f of x is divided by x minus a, the remainder is equal to f of a. When a polynomial f of x is divided by ax minus b, the remainder is equal to f of b over a. That's the first theorem. So let's consider the polynomial f of x equals x cubed plus 3x squared minus 2x plus 1. In part A, we are asked to determine the remainder when f of x is divided by x plus 1. So we know now that the remainder will be f of minus 1. So we need to find f of minus 1. And so that would be equal to minus 1 cubed plus 3 times minus 1 squared minus 2 times minus 1 plus 1. And that'll work out to negative 1 plus 3 plus 2 plus 1. That would be 3 plus 2, 4, 5, 6 minus 1, which is 5. So according to the factor theorem is that when you divide a polynomial by f of in this case f of negative 1, the remainder is equal to 5, right? So that's what the remainder is. This is the remainder. We don't have to divide to prove it. We can just get the answer by using this theorem. Part B says determine the remainder when f of x is divided by 2x plus 3. So 2x plus 3, if you want to know what to do, you can just do 2x plus 3 equals to 0, and x would be equal to negative 3 over 2. So we have to find f of negative 3 over 2. So that would be equal to negative 3 over 2 cubed plus 3 times negative 3 over 2 squared minus 2 times negative 3 over 2 plus 1. And then we got to simplify this. So that would work out to negative of 27 over 8 plus 27 over 4 plus 3, because these two cancel out, right? And plus 1. So we can add these two. Common denominator is 8, negative 27, plus 4 2s are 8, 27 2s are 54. And we can even add this, give it the common denominator 8. So it will be plus 4, right? Sorry, just leave that there, plus 4. So we're going to get 54 minus 27. So what does that work out to? So it looks like 27 over 8 plus 4. That would work out to 27 plus 32 divided by 8, which would be 59 over 8. So that is the remainder when you divide the function f of x by 2x plus 3. And we got that answer without doing the actual division. You can even check using synthetic division to see if that's the answer that you get. Now we're going to look at the second theorem. The second theorem is called the factor theorem. It says that if a polynomial f of x has x minus a as a factor, if and only if f of a equals 0. If x minus a is a factor of f of x, then f of a is equal to 0. If f of a is equal to 0, then x minus a is a factor of f of x. So it goes both ways. So now we are going to try an example. Verify that x minus 1 is a factor of this function using the factor theorem. So the factor theorem says that if x minus 1 is a factor of this function f of x, then f of 1 should equal 0 if it is a factor. So let's check, is f of 1 equal to 0? Let's do f of 1. It'll be 2 times 1 cubed minus 2 times 1 squared minus 3 times 1 plus 3. That's 2 minus 2 minus 3 plus 3. And then that works out to 0, so it is true. So we got a remainder is 0. Therefore, x minus 1 is a factor of f of x. Okay, we'll try another example. We're asked to factor fully f of x equals x cubed plus 2x squared minus 13x plus 10. And we're going to try to do this without actually, trying division. We don't have anything to divide it by. But what we can look at is this number here, which we have 10, and try to find the factors of 10. So chances are one of the factors of 10 will be the a value that will set the function to equal to 0. So we'll start with the small numbers. Typically we'll get the answer with small numbers and we won't have to go very, very large. So, 10 is 10 times 1, 2 times 5. And you can also think of the negative integers, right? Like negative 10 times negative 1 or negative 2 times negative 5. These are all factors of 10. So let's try with the small ones and see what happens. Okay, let's try, what about, say, factor 1? Let's try the 1 that we have here. What is f of 1? If f of 1 works out to 0, then x minus 1 will be a factor, right? So let's check. F of 1 equals 1 cubed plus 2 times 1 squared minus 13 times 1 plus 10. So that's 1 plus 2 minus 13 plus 10. And that's 10, 12, 13 minus 13, which is 0. So that is very good because we got f of 1 is 0. Therefore, since f of 1 equals 0, x minus 1 is a factor of f of x. How does that help us? We are asked to factor fully. So we know that at this point, our f of x equals x minus 1 times something. And we need to find the other factors. All those factors, when multiplied with x minus 1, will give us this function. So let's try now. Let's divide f of x by x minus 1 to get the other factors. So we're going to use synthetic division. And in synthetic division, we have, let's just write the function. F of x equals x cubed plus 2x squared minus 13x plus 10. And we're going to divide that by x minus 1. So then that's going to be 1 here. And then the coefficients are going to be 1, 2, negative 13, and 10. I'm going to bring this 1 down. 1 times 1 is 1, 2 plus 1 is 3, 1 times 3 is 3, negative 13 plus 3 is negative 10, 1 times negative 10 is negative 10, 10 minus 10 is 0. So, we can now find the other factor that's right here. So f of x is equal to x minus 1 times, what is this factor we got? This has to be to the power of 2 because it will times with x to give you x cubed, because the degree of our function is x cubed. So this one means 1x squared plus 3x minus 10. So we now got x minus 1, and we got this 1x squared plus 3x minus 10. Now we can factor this further. This is a quadratic, so we can easily factor this quadratic like we used to do in grade 10, right? What are the factors of negative 10 that add to give you positive 3? It'll be 5 and minus 2, right? 5 times negative 2 is negative 10, 5 minus 2 is 3. So basically, this quadratic is factored as x plus 5 times x minus 2. So that's the answer. We have factored fully this quadratic. And if we needed to find the zeros, well, the zeros will be 1, negative 5, and positive 2. It's a third degree with a leading coefficient that's positive, so it will go from quadrant 3 to quadrant 1, and they're all order 1, so they'll all go linearly through those points. So if we needed to sketch it, we would use all that information to sketch it. All right. Let's try another example. Factor fully f of x equals x cubed minus 5x squared minus 2x plus 24. And then we also have a part 2 to this question where we have to sketch the graph of the function using the factor fully. So we do not know what the factors are, but we're going to look like we did in the previous question at this number, which is, the constant term, and find factors of 24. So 1 times 24, 1 times 24 is 24, 2 times 12. There's so many factors, right? 3 times 8, 4 times 6. And there's also the negative factors, like negative integers. So we're going to start with the small numbers. Let's say we tried f of 1. That'd be 1 cubed minus 5 times 1 squared minus 2 times 1 plus 24. That works out to 1 minus 5 minus 2 plus 24. And you can see right away that there's no way this is going to give you a 0. 24 plus 1 is 25, minus 5 is 20, minus 2 is 18, which is not equal to 0. So obviously x minus 1 is not a factor of it. So we have to do trial and error to find one of those factors from here that will give us a 0. Okay, so let's try 2, f of 2. F of 2 equals 2 cubed minus 5 times 2 squared minus 2 times 2 plus 24. And that's 8 minus 20 plus 4. Minus 20, sorry, it's minus 4. Minus 4 plus 24. So 24 minus 20 is 4. 4 minus 4 is 0. Plus 8 is 8, which is again not equal to 0. So you can see 1 and 2 didn't work. So we always try from the small numbers and hope that they work so we don't have to go to the large numbers. So let's try the next one, f of 3. That works out to 3 cubed minus 5 times 3 squared minus 2 times 3 plus 24. That works to 27 minus 3 squared is 9, 5s are 45 minus 6 plus 24, which works out to 27, 51 minus 51, which is equal to 0. So that works. So this one works. Okay, f of 3, since f of 3 equals 0, x minus 3 is a factor of f of x. So that took all that work just to get there. So we know that now our f of x is going to be x minus 3 times something, 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 and we need to find that. And that next factors or factor we can find by using synthetic division. So let's try that synthetic division. So we're going to do this. Since we know that x minus 3 is a factor, we're going to put 3 here, and then we're going to put the coefficients of the given polynomial. So it's 1 minus 5 minus 5 minus 2 and 24. So check 1 minus 5 minus 2 and plus 24. Yeah. So we're going to bring the 1 down. 3 times 1 is 3. Negative 2. 3 times negative 2 is negative 6. We get negative 8. And when you multiply these two, 3 times negative 8, we get negative 24. And they have to give us 0, which is great. So therefore, our function f of x equals x minus 3 times, well, these are the coefficients of the x, the quadratic we need to multiply with x minus 3 to get this function, which is of degree 3, right? So it's going to be x squared, so that's x squared or x squared, minus 2x minus 8. And we can then factor this further because we're going to find two integers to multiply or give you a product of negative 8 and a sum of minus 2. So that's going to be 4, negative 4 and positive 2, right? Product is negative 8, sum is negative 2. So it'll be x minus 4 and x plus 2. Okay, so let's just try now to sketch the graph of this function. Let's sketch the graph of this function. To sketch the graph, we need to find the zeros. So they're going to be at 3, 4, and minus 2. And its degree is 3. Leading coefficient is positive. So it's going to go from quadrant 3 to quadrant 1, like our y equals x function. So let's do a sketch. Let's say this is our xy axis. We're going to plot our points 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. And we look at the function, you can see that its y-intercept is 24, right? If you put x equals 0, this will be 0, 0, 0, and you end up with f of 0 at x equals 0, the y value is 24. So that's the y-intercept in our graph. So on the y-axis, we might take a different scale. Okay, so this will be 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. Maybe we'll go up by 10s here. So 10, 20, 30, because we need to go as high as 24. 20, 30. So our zeros are negative 2, so it's going to be here, positive 3, positive 4, and we also have y-intercept of 24 right there. So to sketch this graph, we need to start in quadrant 3 and go to quadrant 1 because it's a degree 3 and it's a positive leading coefficient. So we're going to, and we have to, and all of these zeros have order 1, so they just go through it in a linear fashion through all of them. So straight line through there, then linear through 3, and then it has to end back in quadrant 1, so it has to go back up, passing through. Let me just try to draw that again. It goes like that. Okay, so this is a rough sketch of the function. Next example, factor f of x equals 2x cubed minus 3x squared minus 5x plus 6. Sketch a graph using the factored form. It's the same idea. It's exactly the same as the previous question we just did. So we got to find factors of 6. So it could be 1 times 6, 2 times 3, and also the negative, integers of that, like -1, -6, -2, -3. So we usually try the positive, and if the positives don't work, we'll try the negatives. So let's try f of 1. 2 times 1 cubed minus 3 times 1 squared minus 5 times 1 plus 6. So that's 2 minus 3 minus 5 plus 6. So that's 6 plus 2, 8, minus 8, which is 0. So we're lucky we got it at the first attempt itself. Since f of 1 is equal to 0, x minus 1 is a factor of f of x. Okay, so therefore f of x equals x minus 1 times something else. To find that, we're going to do synthetic division. So we're going to put 1 here, and then we're going to put the coefficients of f of x. So that's 2, -3, -5, and 6. Bring the 2 down here. 1 times 2 is 2. -3 plus 2 is -1. 1 times -1 is -1. Add these two, you get -6. 1 times -6 is -6. Add 6 minus 6, and you get 0, which is great. So therefore, f of x equals x minus 1 times, well, this is our quadratic, 2x squared minus 1x minus 6. And we need to factor this. So if you factor this, you probably need to find product of -12 and a sum of -1, and you can factor by grouping. You're going to get them as x minus 1 times 2x plus 3 times x minus 2. So I didn't show the factoring, but I'm just giving you the answer. You'd have to do the factoring to find these two factors. And so therefore, the zeros are 1, and then if you set this to 0, you get -3/2. And if you set this to 0, you get +2, right? And it's degree 3. Its leading coefficient is positive, so it's going to go again Q3 to Q1, just like our y equals x line. Okay, so let's draw a grid to graph this. And let's plot our zeros. Our zeros are, and also we have the y-intercept, right? The y-intercept, I believe, is 6 right here. So we have the zeros. The zeros, which are 1, -3/2, and 2. And then we have the y-intercept, which is 6. Okay, so we can need all these points. So let's say this is 1, 2, 3, -1, -2, -3. So 1, 2, 1, 2, 3, 4, 5, 6. So our points are going to be 1, pass through that. -3/2 is -1.5, and then 2, and then also this y-intercept is 6. So our function is going to go through that. And all of them are linear, by the way, so they're just going to have that linear behavior as it crosses through each function. And that is a sketch of this function. All right, last example. If p of x equals mx cubed plus gx squared minus x plus 3, so if that function is divided by x plus 1, the remainder is 3. And the same function, p of x is divided by x plus 2, the remainder is -7. What are the values of m and g? Okay, so it's kind of like the remainder theorem, right? So when you divide p of x by x minus 1, which is when you do p of -1, the remainder is 3. That's what it means, right? If it's divided by that, the remainder is that. That means when you do p of -1, you get 3. When you divide p of x by x plus 2, the remainder is negative 7, which means p of minus 2 is negative 7. So those are two things that are given to us in the question. What is p of minus 1? P of minus 1, if we substitute into the function, is m times minus 1 cubed plus g times minus 1 squared minus 1 plus 3 equals to 3. And so we have like an equation here. So it'll be minus m plus g plus 1 plus 3 minus 3 equal to 0, or minus m plus g, so 3 plus 1 is 4, 4 minus 3 is 1, we have g minus m equals negative 1. So that's one equation we have here. Now let's try the same thing with this p of 2. P of negative 2 is equal to 7. That is m times negative 2 cubed plus g times negative 2 squared minus negative 2 plus 3. So that works out to negative 8m. That's 4g plus 2. Sorry, I forgot the right side of this. This equals negative 7. So okay, 4g plus 2 plus 3 equals negative 7. So 4g minus 8m equals, so 3 plus 2 is 5, and you bring it there, you get negative 12. So you get two equations. It's almost like a linear system, right? Remember that in grade 10, when you had a linear system and you find their point of intersection, you can solve it either by elimination or substitution. So our equations are g minus m equals negative 1, and 4g minus 8m equals negative 12. What method are we going to use? We can use substitution or we can use elimination. I'm going to do elimination. I'm going to times this one by negative 4. So I get negative 4g plus 4m equals 4. The second one I'm going to keep as is, 4g minus 8m equals negative 12. I'm going to add these equations to eliminate that. Negative 4m equals negative 8. Okay, so divide both sides by negative 4. M equals 2. Once you have m, you can find g. So g minus m equals negative 1. G minus 2 equals negative 1. G equals negative 1 plus 2. G equals 1. So therefore, we have the values of m and g, and we have, the entire function p of x. We can write the values. So it's 2x squared, and then g value is 1, so plus 1x squared minus x plus 3. So that's the function p of x after we got m and g. Now you can practice the questions that are assigned for this section.